Hi all. This is regarding uh, pointers. This is another session after we discuss arrays. So what we are trying to achieve in this particular session, the objective is to learn while pointers, null pointer, dangling pointer, void pointer, Endianness, and let me go through the program and we can discuss in detail while debugging the code itself. So we can use, as always, debug as local application, and it will launch the output console window, and then it is should launch. It is right now in compiler perspective, so it should switch to we have to switch it to debugger perspective. Okay, so this is some memory location I was trying to see earlier in old session, so it is still showing the data. So I've selected hacks. Uh, let's go through this step by step. So we have now in demo pointer types function, and this first pointer, you can see this my pointer is pointer to unsigned integer, and similarly another variable my pointer 1 is also pointer to unsigned integer. So both of these pointers are not initialized, so these are known as wild pointers, both of them. So let's initialize. So not initialize means we have not provided a definite uh, value to these pointers, but definitely because this variable is initialized, so it should have already reserved some temporary memory for this. So that's why you see that value of this my pointer ffc this address, and similarly for another address this this is that my pointer address. You can again highlight the my pointer address, and maybe that is also some junk value, whatever the random value is there. So that is not initialized yet, actually uninitialized. So let's see the right side, my pointer, some old value it is showing that, and let's go through that. So now it is, we have put it 0, that null pointer, although we have now initialized it with 0 value, but still it is not, there is no valid address, means object. This we don't know what this 0 address uh, will basically reflect, and if you are running it this in under Windows operating system as an application, and then definitely this may be, if application run in a virtual memory, then this will be not a valid address. So let's try to allocate some memory address to this. So we can see here some address is allocated already to this one, and now we will try to see that what is the address. And from here you can see 1 byte, 2 byte, 3 byte, 4 byte. Okay, so it is more than 32-bit address. 1 2 3 4, so it is basically 36-bit addressing. And if I go inside this, so this printf we have to use this LX, otherwise it will not print the complete 36-bit address. Step over the left side, you can see the same value, the address here, the hex representation of that. And now let's try to see that address here. This is the same address. We earlier used that same address. I was using this memory window for that, and some values there. Let's try to initialize some value. You can see the change here, but we have initialized 1 2 3 3 4 5 6 7 8, and here we see 7 8 5 6 3 4 1 2. So why this change is there? Let me take you through this Wikipedia reference for Endianness. So here actually two types of Endianness used to be. Number one is big Indian, that is the Motorola concept. You can remember based on that 1 2 3, and other Intel based is basically Little Indian. So that is you can remember 3 2 1. So what is the meaning of this? 1 2 3 means that whatever is written at that MSB side, that is MSB side, this side, that will go to the lowest memory address first. So here we are talking about byte, not digit. So remember, so 0A will go first, 0B, like this. And similarly here 3 2 1 means whatever is our little end side, LSB side, will go first to that. You can see here 0D 0C. So that's why this, while writing and while reading, this will be this will take care of the same thing, similar way. So when we put it is like this. So wait, so what value expect now of this data when we take that using this pointer? What value we should expect? This one? No. Let's see. You will see that value is basically correct, because it will the similar way it will read, so it will take care of that thing. And let's go to that another void pointer demo function. Let's go a step inside that, and in that what we have done, if you see the we passed we basically from this function we pass my pointer value there. My pointer, we know that value was basically this value. Okay, so my pointer was this value and it was passed to that one, and then here we called this particular function void pointer demo void pointer my pointer, and in this particular case we have this is not given as a pointer to unsigned integer or whatever. It has been passed as a pointer to void. So it means that we can cast it to any other pointer type. Let's see how. So first one, you can see that unsigned character X, so that is the byte basically. If we step over this, let's see. So my pointer, what we have done, the now my pointer value was whatever earlier it was, we passed that particular so my pointer right now is this one. So this is anyway uninitialized, so void pointer right now. So it is being initialized by temp. And what is temp? temp we pass the same address 6000, and then step over, and let's see my pointer on right side. You will see this address, and this address we know the data is this right now. Okay, so it will print this particular address here. Okay, this my pointer is basically the my pointer is basically the pointer defined here. So this in this particular function, not in the previous function. So this scope is the local one. Now that's why, but we have passed the same temp pointer, so value will be similar, which was using earlier, this one. Okay, so let's verify that my pointer is this. So don't confuse with this, as this is just a printing here, and once it has printed this particular thing, then wait, what value you expect now? Okay, we know this address is this one, so what value it should print? Make sure that we have this particular my pointer is pointing to unsigned character, that is byte, and its address is this. Okay, so if this is the address, only one single digit, so I think it should print this one, because we have only one byte, not multiple byte, that it should, we should think about little Indian or big Indian stuff here. Let's go further. So 78. Now let's take another example. X is one local variable which initialize AB, and we have taken address X. Okay, so again wait, what value you expect? So here X is again unsigned character, and AB, so definitely the answer is simple, that AB, that because single character doesn't matter, single byte it doesn't matter, that little Indian or big Indian, there is only one location. Anyway, whenever it will print it, this side the sequence will, it will take care of the sequence. Main thing depends on that what the way it is stored in the memory. Let's take another example to understand this better. Y. So y pointer is y is basically one unsigned sort, that is 16 bit variable, and ABCD we have initialized, and let's see my pointer 1. What is the address of this? Step over. So you will see that address of my pointer 1 will be this one, CB1C. So this is the second one. Let's see hex. So here we can see it has ABCD. So because it is, again it has taken care of this time that Endianness, because it is a little Indian, so AB first, CD second. But again that data it will display will be correct order, that is ABCD. Okay, I hope this is clear. Let's try to understand that another concept of pointer, that is Dangling Pointer. Let's go to that one based on the scope. Let's see first test pointer. This time we have initialized it to the null, so this is the null pointer. Further, and if it is not null, so we know that not test pointer means not test pointer is null, so definitely it will go inside this. So it was done deliberately, and go inside, and again x equal to this. So you will see that test pointer is the address of x, and test pointer definitely it will display that 1 2 3 4. Okay, now unsigned integer is, suppose y equal to 5678, and then y address this, and again this case y simply it will address whatever the address it has, temporary memory. Please note that y is a temporary variable here, so it has been assigned one address temporary, and based on the stack, and the value is assigned. So that's why we are getting this particular address. Okay, now the question is here, why the following statement is commented, this one. The reason is very simple, like it is using this x variable x, and x, the scope of x was up to this this portion only, and after this if I remove it, so it will give compiler error. So that's why now if I try to test pointer was the address of x, and x is, so text pointer anyway, the text pointer for this is still valid, correct, the scope is there, but the value assigned to this one was address of this, so that is not valid. So that's why it is called dangling pointer. So although it may display this value same, because this probably this address is not being utilized by any other, and we are working on a single process kind of application. So if it is not being used by any other, so you simply step over, probably you can get the same, but it is not guaranteed always. Okay, so this is not recommended. So let's go to another example of dangling pointer, where I can demo you that how basically it works. So let's see. Okay, so here we have my pointer. Again we have come back to this our my pointer, and my pointer address, this one was the my pointer address, this one, and we had value 1 2 3 4 5 6. So we are releasing this particular memory now. We have allocated this memory using malloc, now releasing free. We will free this so that any other one can use it. Let's step over, and you will notice some change here. The data not guaranteed now. What is the data? We don't know. Now let's take another pointer, my pointer 1, and because we have freed that particular pointer, that was this one. Let's try again. Let's try to initialize that particular pointer, step over. So my pointer 1, let me check what is the my pointer 1, what value we got my pointer 1 now. My pointer 1, we got same value because it was free. So memory allocation provided it same value. Now what we will do, we will check, it will go inside, initialize it, and it will just print here, okay, this address was this address was AABBCC. So you know that my pointer, although that my pointer address, this is the my pointer 1, and this my pointer it was freed here. So although it was free, but this particular location is still showing the same address. Okay, so although initially in that address we have written 1 2 3 4, then that was overwritten by some junk value, and because it is still showing the same address, so it means that it should display this value. The address is there, although it was freed. So let's see that. So same value. So this is dangerous actually. For example, if this value was this pointer was freed, and if you accidentally use that pointer or you this time we are just reading, so no issue. But if we write to that particular memory location, then it is not recommended. Okay, thanks for watching this. That's all for pointer. Now we will uh, come with some another interesting video on this pointer, and please uh, subscribe this, or if you like it, then thanks for watching this.